Do you got questions about running AI locally? I've got a bunch of answers today to the most frequently asked questions, and I get these quite often, so I can easily point back to this video. Today we're going to be looking at things like who makes the best GPU for locally hosted AI? Do you have to have a GPU? Can you use CPU? What about these specialized AI chips? Apple, M4, M3? We're going to also cover things like SLI. We're going to look at what dictates performance, which is a key concept that will help you understand what you're going to expect and what you could expect and how to extrapolate expectations based upon your hardware. And of course, we're going to be looking at some things like security and also where is Deepseek R2. So I hope you are excited. Let's get started on these questions. We're going to start with probably the most common one that I get, which is who makes the best GPU for AI? And it is NVIDIA. Let me tell you right now, there's not even a comparison that's close. However, AMD is making good strides, and hopefully in the near term, we could see some advancements. Things like tiny grade are really interesting and making pretty big strides in the AMD realm. However, NVIDIA is an MSRP disaster if you're looking for new. Certainly the 5000 series, if you're on YouTube, is probably flooding your feed right now with those disasters. AMD with the 9070 XT hit a really good ballpark win. However, there is a little bit of a problem with that, and that is the price of theirs has gone higher than their MSRP also. Nobody wants to pay significantly higher than MSRP. Intel is like, I would say they're a trick, kind of. They always talk about these really great sounding products, and then they're not available for even close to MSRP. We have the B60, a 24 gigabyte GPU that sounds just amazing. The price sounds like it's going to be great, but its availability, like all of Intel's Pro lineup, is very likely to be seriously restricted. I have very, very bad feelings about that. Intel keeps missing the chance. At least they could beat out AMD, but we'll have to see. For now, NVIDIA is typically the best. And so that usually leads to the next question. Which specific GPU in that lineup is going to be the best? This, of course, comes down to budget and price preference. And we're going to talk about system bandwidth here in a second, and that should dictate and should make a lot of sense to you after we're done talking about it with the performance you could expect to see out of a local AI inference model. Now, if you're looking at probably the best bang for the buck, I hate to say the 3090 is still probably the best bet, and that is because it has 950 gigabytes per second of system bandwidth per GPU. 4 of them, they've got 950 gigabytes per second per GPU, and that does give you some potential for parallelization. However, this is a very frequent question also that I'm going to answer for you right now. Can I speed up by running more of the GPUs at the same time on the same rig? There are some ways to do that. However, usually the way that people set this up and run it, it does not work like that. So you should not expect a performance gain. You should expect a VRAM gain. So that maintains your performance of that as a single GPU, but it gives you a much larger VRAM footprint. That allows you to run very large context windows. Very large context windows are incredibly important to running a really good local AI experience. You want to have a long-ranging conversation. The context window is, of course, measured in tokens, and how many tokens you can back and forth gets eaten up fairly quickly as your conversation grows, because your prior chat history is sent back each time also to the model. Now, things like KV caching have helped that out quite a bit, and there are other advancements that we certainly see that do look like they are making some strides to tame that impact a little bit more, but still you do want to have as much VRAM as possible. So always bias for VRAM. In most of the affordable class cards, I'm not going to talk about the data center cards or the Quadro crazy Blackwell things that are out. I'm going to talk about pretty normal stuff. The 3090, 24 gigabytes of VRAM, about $850 on eBay right now, is probably still one of the best bang for the bucks that you've got out there. The 4090 has only 1 terabyte per second, a little bit more of system bandwidth, and that really doesn't get you very much as far as inference. It does get you more if you're looking at image generation and video generation. We'll talk about that here in a second. But definitely it is significantly more expensive than that. 5090s, well, you would need to make your own decision on that. I don't think the price per gigabyte of effective VRAM, even though they have 32 gigabytes of VRAM, is even close to what you see for a 4090. You do get 1.6 to 1.7 terabytes per second of effective performance. So your performance is actually greatly improved on that class of a machine. If you can get 5090s for MSRP, for instance, oh wow, that would be a great deal. But you can't. That's kind of the MSRP disaster that NVIDIA is in currently. Seem to always be in that. Next question, SLI. Don't you have to have SLI if you're using 3090s or you want to effectively pool VRAM between GPUs? No, not at all. It does have benefits for things like fine-tuning and training. If you're into fine-tuning and training, this probably is not the FAQ for you. The NVIDIA SLI NVLINKs are also really expensive. I think they're $250 or so for each one. And you can only link 2 cards together. Now that could give you 48 gigabytes of effective space, and if you're doing things like image generation or video generation, that very well could be very useful to you. At the same time, you're not going to see a performance improvement for inference, and it's not necessary. I get this question all the time. Actually, I get usually statements that go along the lines of, you have to have NVIDIA SLI to be able to utilize multiple GPUs. No, not at all. You can absolutely, like this machine here, use all 4 of these. This gives you 96 gigabytes of effective VRAM space because that's 4 times 24, and that is allowing me to fit quite a big model and context size into it. The next thing that I got to talk about is how to read and understand a model. So like when you go to something like llama and you're looking at what it is telling you for the example, let's say 27B or something like that, that is parameters. That's 27 billion parameters. Next, you're going to see a quant presented to you. The quant is basically a reduction in size or a compression, if you wanted to look at it, per bit that is stored. And there's multiple layers, so that has a fairly big impact. Q4 is pretty much where you want to draw the line in going down to, a size. Q8 is going to usually give you very good performance. Each layer, essentially, you're looking at the number of choices that you'd be able to make for the next token, and that next layer is going to be either 16, 256, or however many it is in an FP16, which is quite a few. You definitely want to opt for what can get the largest number of parameters first, so the B size first, and then you want to get a Q that is good. Usually Q5 is what a lot of people are talking about as a very decent size. There's also things like Bartowski and, of course, Unsloth that can lead to improved results. So you should definitely check out things like Unsloth. You can check the history on this channel. Big shout out to our channel members also. Thank you for all that you do for the channel. You guys really do make all of this possible. VRAM 101. Okay, how does VRAM work in local AI for inference? So yes, shared among all the GPUs. And you can speed up in parallel in some instances. However, it is also not quite the gain that you would expect. It's not like doubling. So that is something to keep in mind, and that means you can only run a much smaller model. Typically, you're much better off running a much bigger model. This is why this is not necessarily a popular choice, because you want to run the bigger parameter model. How do you do that? You do that by having all of the VRAM available to pool together and run that big, fat parameter size model in. See how that kind of all paints a picture of what the optimal scenario is. Definitely, if you're looking at what you should expect to get a really good performance or a good target, 24 gigabytes of VRAM, however you get there. That could be a $500 machine. That could be 24 gigabytes of system RAM. That could be, a 32 gigabyte basically desktop. We'll get to that. That's pretty exciting. Did you listen to that? That is everybody. Everybody can run an LLM. Big question there. Or whether you're looking at something like a 3090. The biggest difference is the performance that you're going to get as far as your tokens per second. And I do like myself to be at a minimum in the teens. Of course, as fast as possible is the best if you're doing code work, because you're going to have a lot of iterations back and forth. And so now that we've talked about the amount of VRAM, let's talk about something that is important a little bit more in detail. I mentioned it earlier. This is system bandwidth. And your bandwidth is actually not just something that you would measure on a GPU to VRAM. Bandwidth is also something that you would measure on a CPU to normal RAM. And if you think of it this way, it'll start to make sense. Bandwidth is data volume. So the more data volume you have, the more data can be shoved down the pipe, the better you are going to get as far as the performance. So your effective bandwidth is going to be the primary dictating inference performance metric you're always going to see people refer to, and for good reason. It is the most important metric out there. So next, don't you have to have GPUs or a special AI chip to run AI locally? No, you don't. If you got AVX2 on your chipset, which is like Haswell, I think, then you're going to be good to go. Actually, it might even be older than that. It might be Sandy Bridge. So you can go quite a ways back and still be able to run pretty darn effectively. Now, if you look at the way that bandwidth is measured in a GPU, it's a very static number. You get very consistent performance, and GPUs are basically optimized for this kind of processing very well. And there's not a ton of stuff that you can tweak inside there. Maybe at a very fine software level you could, but that's the stuff of very, very advanced engineering. If you are looking at a CPU and system RAM, well, there's a lot of things you might need to know to get the best performance if you are setting something up. And I'm going to go through those things because that's quite important and something I have made a lot of effort on this channel to let people know. There are cheap ways to run things even like Deepseek 671B on a $500 class workstation from 10 years ago, like a Z440, which can run 512 gigabytes of LRDIMM DDR4. Yes, got that question just the other day also. Can you really run 512 gigabytes of DDR4? Well, yeah, the video showed me doing that, and it does have a nag screen, but totally able to be done. And so being able to run that at a fairly decent amount of gigabytes per second is actually something they do. And you got about 70 gigabytes per second of performance bandwidth on a V4 class Xeon. That's pretty cool. You might not expect that. Now that is with all the RAM slots populated, but RAM slots populated in DDR4 is dramatically cheaper than VRAM for GPUs, if that makes sense. Think about it like this. You're probably paying about $1, maybe max, for most of that, maybe 50 cents. DDR5, maybe you're paying upwards of $3 per gigabyte, maybe lower. Depends on the density you're going to go with. VRAM for a GPU, you're going to be paying $10 plus for each gigabyte of that for most of the GPUs out there. So like I mentioned, 70 gigabytes per second of performance on a V4 Xeon. This is why we were getting 2 tokens per second on Deepseek 671B with a Q4. Not great by any stretch of the imagination, but still pretty doable. If you're looking at a system like this is a Rome. This is a 7702 64-core Rome, Genoa. Those are V2, V3 kind of class. AMD EPICs. Those are not super new either. They're pretty affordable. This is about 200 gigabytes per second. And they have 8 RAM channels. That's a lot of RAM channels, right? And that gives you a lot of performance because you can hit right around 200 gigabytes per second. That is with all of them populated, of course. If you look at something like a 9004 series EPIC, these are much more expensive, and these are DDR5 systems. You're looking at 400 gigabytes per second of system bandwidth. If you're looking at a top-end 9005, you're looking at about 600 gigabytes per second for the very top end of those. And that's, of course, with 12 channels. So this is something to keep in mind if you're looking at Threadrippers. I don't think there's a single Threadripper board out there that you can actually buy that has more than 8 channels on it. This is a little bit disturbing if you go with something like a 7995WX, like I did, and you discover that you are pretty much going to be limited to those 8 channels and you're leaving performance on the table because they don't make a 12-channel variant motherboard for that. Ouch. Ouch, ouch, ouch. You will have a CCD to RAM channel kind of performance metric. The higher number of cores is going to be your highest performing chips out there. Multi-socket systems. Can I just get a multi-socket system and double the performance? That's a pretty common question. No. Multi-socket systems are complicated because they have bandwidth between each of the sockets, and the RAM is not shared exactly 100% at full speed between them. So that interlink between them becomes another bottleneck. You're going to slow down to whatever the slowest thing you hit next is. So if you hit a PCIe socket, if that is like, say, a Gen 5 PCIe socket, that's 64 gigabytes. That's going to slow things down to 64 gigabytes per second. That would be your max theoretical. With CPUs and RAM, not at all as easy as a GPU. So it takes a lot of tinkering, it takes a lot of system knowledge, and it takes a lot of things like following the guides that this channel's produced to get the maximum that you can for performance for something like local AI inference out of a machine like this if you're running purely CPU on it. And if you look at what it scales up to on even the highest end Apple Silicon, you're going to be looking at 240, somewhere in there, I guess, for the performance on their pretty much built for AI specifically 512 gigabyte unified RAM setup. Now, I think that they're onto something here but they've got to get the price down. 10K for 512 gigabytes of RAM. I mean, if Deepseek R2 comes out and cannot fit inside that, people are going to be a little bit like, hey, Apple. And you can hit on Deepseek R1 about 5 tokens per second. That's not bad. That's not great. Especially considering that on this, a 2K 512 gigabyte ROM, you can hit 4 tokens per second. And that's with 2400 speed RAM. Cheap, old RAM. And you can actually grow the amount of RAM in this, whereas with an Apple, you cannot. You do get lower idle wattages, so that is something to consider. But this dude here, actually, if you didn't have GPUs on it, idles all the way down to 65 watts, which is pretty darn good. AMD, Halo, Strix, chips. 128 gigabytes max, so that's going to limit you in the type of model you could run pretty heavily. They're right around $2,000, and they're about 240 gigabytes per second. So you can talk about things in terms of gigabytes per second of system bandwidth and start putting them in line. Like, you're not going to necessarily blow things out of the water. You do have 128 gigabytes of RAM, but the reality is you can throw 128 gigabytes of RAM in almost anything and be able to run that size. Now, at $2,000, you do get some benefits to that. First off, DDR5 runs pretty darn fast. And if you're looking at a common like Ryzen desktop right now, just the way that they're architected, they're not optimized for performance necessarily like I wish they were. So you're still going to cap out somewhere maybe about 80 gigabytes per second on your most, latest and greatest Ryzens out there. A lot of people asked, well, you have a CPU-based rig here and you have a GPU-based rig here. Do you use them at the same time? I can use them at the same time because I'm using virtualization technology, and that allows me to run different containers. I run containers because that allows me to efficiently share GPU resources between multiple different processes at the same time. Now, yes, there can be some problems if you run out of RAM on them. That can cause an issue. But it's better than a virtual machine, which actually locks the hardware down to that virtual machine's instance, and it can't be accessed by another process outside of that. If I am running a VM and running a container, an LXC is my preference now, a bit over Docker, and they both use the same GPU, what happens? Your system will lock up, so don't do that. It will require you to hard power down and repower your system. So, video generation and image generation. These are not something I'm going to dive super deep into, but definitely, if you're looking at them, you want to be able to optimize the amount of VRAM you have. Definitely, this is where GPUs are pretty much mandatory. So GPU only, and you want to optimize for the maximum amount of RAM that you can get and the performance of that particular GPU. This is really the realm of 5090s, 4090s, and 3090s. Could you use NVLINK with a 3090? I need to test that out and actually see what the difference is, but I'm gonna guess you can. Now, with video generation, you can use things that have and incorporate the Ulysses engine for multi-GPU. So it can handle multi-GPU for video generation. Still pretty slow. You can check out some of the videos in this channel's history to see. I need to do an updated WAN 2.1 now that they got the VAC out, and that actually looks like it's pretty darn interesting. Okay, so we've covered a ton of performance topics. If you've got more performance questions, specifically drop them in the comments below and I will try to answer you. Also, if you've got tidbits and bits of knowledge that you think are fairly common, drop those down there also. People do read these and a lot of comments and a lot of conversations happen in those comments. Let's talk about some security and some very, very common questions I get around things related to DeepSeek. So if I use a local AI model from China, it must be sending my data back to China, right? This is a pretty common assumption. So if you have downloaded your app onto your phone and you are using the DeepSeek app, yes, that is definitely sending your data to China. So if you upload documents, if you upload a chat, that chat and those documents are going to China, for sure. However, if you use a third-party model provider, no, they necessarily wouldn't. I would say that you're best off, though, going with your own local AI if you're thinking of running that, because you can also be sure in that scenario that you fully control the data lifecycle of your data, which is very important. And in the instance of running something like Deepseek R1 locally on the 671B variant, I do have pretty decent networking filtering and monitoring, and I make sure that I have any traps set for any communications that would be outbound and heading to China. I have never seen that. But none of the LLM machines, I know their IP address, I go back and review their history of their outbound communications. They only communicate to the local client IP. And the other thing is, an LLM does not necessarily work like that. People think, hey, it must be kind of like I'm downloading an executable. No, it's not. It's more like you're downloading a database or an encyclopedia or a dictionary. It's more of a data store of relational data that's compressed in very interesting, very, very, very interesting manners that is highly efficient and also incredibly relational, but it is not a standalone application. You cannot run it by yourself just without a runner. You have to have like a llama or llama C++ or VLLM to actually be able to utilize it. Make sure that you are getting stuff from an official website. Like if somebody just shows up randomly, maybe on X in the comments somewhere, and they're like, hey, check out my new model, don't do that. Because honestly, there's a lot of ways to deliver a lot of things that aren't even models. So definitely be only going to mainstream, semi-mainstream sites to download your stuff, and make sure that there are other people that have checked it out and kind of maybe commented on it before you get into it. Second, is local AI insecure? No, I would say one caveat. I actually went out and did a lot of looking around this. Don't ever download anything that's a pickle file. Very rare to find those. Looks like Hugging Face had a couple pickle files that may have had erroneous code in them. They did pull those off the market. Hugging Face is typically not where you're going to go if you're a beginner. Llama is where you're going to go. And how do you get started? Check out the guides that I've got on how to put together the software and the hardware, all of those things in the channel history, and definitely lots of that in the channel history. Check out the playlist that I've got also, which will take you through all of that. If you're into AI, for sure, that is something that you should be using. As something like a llama, something like llama.cpp, especially things like LM Studio, are going to have a lot of eyes on it. So I would say if you are a single user, how do I go about setting up a local AI? Simply download LM Studio is a good way on a desktop to use that. It will be an application, a standalone application on your desktop that you'll use, but it has a lot of functionality. Works on Apple, works on Windows, works on Linux, pretty easy. If you want to go a little more complex and have services that are communicated to from third-party software like OpenWebUI, then Llama is probably one of the ways you want to go, or llama.c++ or COBOL. There's GGML under the hood of both Llama and LM Studio. I don't feel like they may not get quite the kudos they deserve, and so definitely Llama uses them, LM Studio uses them. It's good software. Next question, when Deepseek R2? So my standard answer to that now has become next week, and so whatever this week is, it's always next week. Seems like it covers all the bases. Actually, my real speculation is that it could be timed, and this is interesting because I believe it is the 27th or the 28th of this month, May 2025, when NVIDIA's next earnings call is going to happen. This is rank speculation on my part, but certainly they had an interesting impact last time on NVIDIA's stock, so I thought to myself, what is the most likely time? We'll see. It could be Wednesday this week. If the results are not looking good, then hopefully they're hitting the brakes on it and they're not going to put out a Llama 4, which was not the strongest release we saw recently from Meta. Behemoth, the Llama 4 Behemoth, maybe they are taking that one back to the drawing board and making sure that it's better. I'm not sure exactly what's happening, but Llama 3, wow. It actually got me very interested into AI, Llama 3 specifically. And it was a pretty big open source generational improvement. Llama 4, feels like they missed the mark a lot. But the bar is fast rising and there are lots of good competitors, especially people like Quinn releasing all the time. You've got open source things like AI2's, various different OMO projects out there, News Research, which is, I think possibly one of the most exciting with their ongoing training of their model in a distributed inference kind of setup. Very, very cool. So what is the best local AI model right now is a question that I get all the time, and that changes literally all the time. Usually whatever has come out kind of recently is going to be state of the art, for locally hosted especially. Right now, at this moment, Gemma 3 is what I use for like non-coding assistant related tasks. I use it all the time for planning content, for creative writing assistance, and also if I am looking for guidance or planning out a pretty complex piece of content, it really is incredibly good at doing that. It also has great built-in vision support, so you can literally send it a picture of anything. So you can be like walking around like, what's that bug? What's that bird? What's that whatever? And it will be able to identify it quite well. It does really good also with image to text. So that's something to keep in mind if you like to scribble down notes and you would prefer them not to be scribbled down. Quinn 3, great general all-around model, and definitely has a lot of just very to the pointness to it. It's not a rah-rah model, it's a very professional kind of model. There are specializations, and this is where I would say this changes all the time, and the best way to know is to define what you are looking for as far as use cases. And I've got tons of use cases that you can check out also on the website here, but testing to fit your use case is the best way to do that. OMO OCR is probably the best OCR out there right now. And of course, if you're looking for reasoning and deep complex thought processes, Deepseek R1, by the time this is released, maybe it'll be Deepseek R2, and the 0324 of the V3 is probably some of the best stuff. Big beefy machines are needed for that to run it locally, big beefy machines. You can also run it on things like a Z440, but with a lot of RAM. And the final question that is very frequently asked, is this actually free? Well, you do pay for electricity, and if you have the hardware, well, you've got the hardware. If you don't, well, you pay for the hardware. But otherwise, yes, and that's one of the biggest reasons to use local AI. Another huge reason is privacy concerns, and a lot of people don't value their privacy. Kudos to you. If you don't care about your privacy and your data being basically for sale to whoever, whenever, whatever, and in whatever format, there's a lot of cloud providers out there that could fit the bill for you quite nicely. So that is a ton of frequently asked questions that I get. I'm sure there'll be more, and this could be an ongoing thing that we do frequently. So like I said, if you've got questions, drop them in the comments below. And if you've got pithy suggestions and ideas, drop those as well. And so if you're interested also, you can definitely join as a member for $4.99 or more, and that supports the channel. You can buy me a coffee, or you can hit me up on Patreon. Big shout out to everybody that does that, and I do appreciate that quite a lot. And you can buy me a GPU. It's not buy me a coffee, it's buy me a GPU. And I appreciate that also. Everybody have a great rest of your day, and I will check you out next time.